Hey everyone, welcome back to the channel. And today we're following up on the MD Helicopters MD530F accident near Superior, Arizona that occurred on January 2nd and tragically claimed 4 lives. Since the last video, the NTSB has released its preliminary report, which gives us a bit more information about what they've documented so far, while still leaving many important questions unanswered. If you haven't seen the earlier video, that one focused on the possibility that the helicopter may have struck a slackline in the area. Now, the NTSB report is here and we have a few more details to consider. Let's take a closer look. My name is William and you're watching Black Box Analyst. The NTSB has confirmed that the helicopter struck a slackline, causing significant damage to the rotor system that ultimately led to the loss of control and the crash. We already speculated this could be the case, but now we have confirmation. This was the primary cause of the crash, and the report clarifies that no other traditional aviation hazards like power lines or towers were involved. This is an important detail for a few reasons. First, it shows that slacklines are a real hazard, and they present a completely different set of challenges compared to the typical obstacles pilots are trained to look for. Slacklines, unlike towers or power lines, are invisible from a distance. They don't have the vertical structures that we're used to seeing in the sky, and they're typically placed in areas where you'd never expect them. What does this mean for pilots? Well, this is a recognition problem rather than a case of pilot error. Pilots aren't trained to look for slacklines, and in many cases, they wouldn't even think to check for them. It's not about negligence. It's about being faced with a new type of hazard that doesn't fit the traditional mold. In terms of mechanical damage, we know that the rotor system was struck, which is no small issue. The NTSB suggests that the damage was severe enough that recovery from the strike wasn't possible. We'll have to wait for further investigation to know whether this damage was immediate and catastrophic, or if recovery was even possible before control was lost. But either way, the slackline was the critical factor. Now, let's talk about the visibility challenge. The NTSB report confirms that the helicopter was flying at low altitude in a canyon environment, where the slackline was incredibly difficult to detect. This is a huge point to emphasize, because we often hear about low altitude flight as a normal part of scenic tours, and it absolutely is. But when you're flying low over uneven terrain, obstacle detection becomes much more challenging. Canyons, in particular, create all sorts of problems for pilots when it comes to spotting hazards. The lighting is uneven, and there are shadows and rock faces that make it hard to differentiate between the background and a potential obstacle. Add to that the fact that slacklines are thin, high-tension lines, and they're practically invisible at any kind of distance. Even in good visibility, a slackline can blend right into the environment. There's just no contrast, no vertical structure like power poles or towers. It's difficult, if not impossible, for pilots to see something that doesn't stand out visually. Now that brings up a crucial point. Terrain following operations are common, but they come with inherent risks. The closer you fly to the terrain, the less time you have to react when an unexpected obstacle appears. We're talking about a real challenge to visibility in certain environments. Pilots need to adjust their expectations for obstacles when flying in areas like canyons, where slacklines or other invisible threats can be hiding. This isn't to say flying low is inherently dangerous, it's normal for scenic flights. But this crash emphasizes that visual cues are reduced in challenging environments, and pilots have to work with a much smaller margin for error when flying close to the ground in rugged, unpredictable terrain. So, for pilots and anyone involved in aviation safety, this incident serves as a wake-up call. Low altitude flying in canyons or rugged areas requires a different mindset. Obstacle scanning needs to be more thorough, and pilots need to be prepared for the unexpected. Let's move on to the NOTAM system, which is another critical detail from the NTSB report. As we discussed earlier, there was a NOTAM for a temporary obstacle in the area, but the NTSB's investigation reveals that the information was buried among unrelated NOTAMs. In other words, the safety information wasn't clearly visible or actionable for the pilot, which means it didn't serve its intended purpose. So what went wrong here? First off, let's talk about how NOTAMs are supposed to work. They're meant to be a warning system, a tool that pilots use to stay informed about temporary hazards like construction zones, obstacles, or airspace restrictions. But the problem lies in how these warnings are presented. A NOTAM for a temporary obstacle, like a slackline or highline, can get lost in the shuffle when there are dozens of other NOTAMs for unrelated things like airport closures or runway conditions. Unless the pilot is specifically looking for that particular hazard, it could easily go unnoticed. The NTSB report clarifies that the NOTAM system didn't do its job in this case. If this obstacle had been more clearly highlighted, or if the delivery system had been designed to prioritize critical hazards, the pilot might have been more likely to spot it during pre-flight briefing or during the flight itself. But as it stands, the critical safety information wasn't as visible as it should have been. This brings us to a bigger issue. The efficacy of the NOTAM system needs to be questioned here. Pilots rely on these alerts to be timely and easily actionable. If vital warnings are buried among unrelated details or presented in ways that aren't immediately clear, we've got a serious communication gap. It's not about pointing fingers at the pilot here. It's about recognizing that the system failed to deliver the most important information in a usable format. For aviation professionals and enthusiasts, this is a wake-up call about the limitations of current safety systems. The system works on paper, but in practice, it needs an overhaul. We need to start thinking about improving the way safety information is delivered, making sure that pilots don't have to dig through a mountain of unrelated data just to find the one alert that could save lives. Now, let's talk about wire strike protection systems, which are another key topic from the NTSB report. The initial assumption when people hear wire strike protection is that it's a catch-all solution for all kinds of wire-related dangers. But this crash shows us that these systems are limited in their effectiveness, especially when dealing with non-traditional obstacles like slacklines. Wire strike protection systems are typically designed for rigid steel wires that are placed under predictable tension. These wires are fairly stiff and don't move around much. The system works by using a cutting mechanism that engages when the aircraft makes contact with the wire, cutting it before it causes major damage to the rotor system or other vital parts of the aircraft. This is great when it comes to traditional wires, but it doesn't work in the same way with a slackline, which is flexible, elastic, and designed to behave very differently. The problem with slacklines is that they can deflect, wrap around, or strike parts of the helicopter in unpredictable ways. Because slacklines are not rigid like steel cables, they don't behave the same way, and therefore the traditional wire strike protection systems may not engage properly or may fail entirely. For example, if a slackline wraps around the rotor system, it could cause damage to the rotor blades that the system wasn't designed to handle. The cutter could miss entirely, or worse, it might engage in a way that actually causes more damage to the aircraft. This is a mechanical complexity that these systems simply weren't built to handle. Wire strike protection systems are not designed for this kind of elastic, unpredictable hazard. And because slacklines are invisible and non-traditional, the system wasn't prepared to react quickly enough to prevent the damage. This accident shows us that current protection systems, while effective for certain hazards, don't cover all possible scenarios. If we're going to make aviation safer, we need to start thinking about evolving these systems to address new threats like slacklines, which defy the conventional models of what we consider a typical aviation obstacle. For aviation system developers, this is a major lesson. It's not enough to assume that traditional wire strike systems will be effective in all situations. We need to start designing more adaptable systems that can handle non-standard obstacles like slacklines, high lines, or any future hazards that don't fit the typical mold. So, as we wrap up, we now know that the crash occurred after the helicopter struck a slackline while flying low in a canyon environment. The slackline was difficult, if not impossible, for the pilot to see. The NOTAM system failed to deliver the crucial warning, and even if the helicopter had a wire strike protection system, it wasn't designed to handle a flexible, elastic line like a slackline. The key takeaway here is that invisible obstacles like slacklines pose a serious risk to pilots, and this incident shows us that even the best safety systems can only do so much. This crash highlights a new class of hazard that wasn't on the radar, and it's up to us to rethink our safety systems to account for these evolving risks. If you found this helpful, please consider subscribing for more updates and other aviation safety topics. Drop your thoughts or questions in the comments below. Let's continue this discussion. There's a lot to learn from this. Thanks for watching. Fly safe and see you in the next video.